Okay, welcome to this week in SU2, another week of good content for you. So I'm joined here with members of the team. We've got Santiago, David, I'm Tom, we have Francisco, Andrew, and today we have two people in the control room, which is pretty exciting. We've got
this is the number of people in the control room.
Better control. So we've got Anakin and Anil over in the control room, so they'll chime in.
Next time we will have 6 people in the control room, 2 here.
Yeah, we're just going to keep moving people that way. Okay, so a couple interesting, exciting announcements for you before we jump into the content for today. First, you may have noticed that we released version 3.2.3. This is pretty exciting. We've got a couple new features in there that you'll want to check out. First is some updates to multi-grid, better the robustness. Did you want to say anything about that?
Yeah, we have improved the method that we have to agglomerate the cells. We are still working on that, but we are close to have a better multi-grid algorithm. We have removed some options from the multi-grid, so now you don't need to choose what the CFL number that you want in your course level is automatically chosen. And damping, we have remove some options that we think it could be chosen by the
try to make it easier to use.
Yeah. Easier to use, yeah.
One other thought on that, we also have US units now available. That's been well tested, I think, so be sure to check that out.
Important details, the geometry should be in inches.
Yeah, inches.
So internally it's feet, but the grid should be in inches.
Okay, and then also yesterday, if you're on our developer list, you would have noticed that we had a very nice email that came in. And before we jump into that, we're going to talk about that for a little bit. I do want to say you probably also saw an email from us yesterday about SU2 on YouTube. And we're trying to advertise that we're doing these shows, and also we want to get a little bit of feedback. So in that email, there was a link to a survey asking you kind of how you feel about the format of these, if you want more discussion, more questions. What kind of content you want to see, users or developers. And actually that segues very nicely into the email we got yesterday to the developers list from Pyam. So he wrote us a nice email with a lot of discussion points about how we can kind of get involved or how, to really engage the community, either users or developers, and how we can sort of get people working on SU2 more actively. So the first thing that he brought up, which I think we should discuss a little bit, is really, who's the target group for SU2? Who are we wanting to get involved? How do we target our material, and who are we trying to speak to? So
yeah, I think he proposed 3 different groups, so maybe we can remind what are the groups that.
Yeah, so there's this idea that there are a bunch of users out there, folks who are relatively new to CFD. Mm-hmm. There are folks that are maybe in the middle who are using it or want to start developing it, and then there are also folks who are hardcore developers. And so there's this idea of maybe the users group is the biggest, and should we be targeting the developers?
Yeah, and the user group should be order of magnitude bigger than others. That's a natural thing.
For what we've seen, the users group tends to be, like Francisco said, the biggest, but the idea is to take some of the people from the users group, and by showing them the features and helping them get started with SU2, be able to continue and move towards being developers, get more involved into the code, not just use it, but also start adding features that they will find useful for their own work.
Well, I mean, I think also, like, someone who's a user doesn't necessarily have to be new to the code, right? I mean, you could have people who have been running CFD for 20, 25 years who aren't necessarily actively developing algorithms, but they're actively expanding the number of test cases they run in different simulations, and might be post-processing to get different results. And I don't know if you'd necessarily call them CFD developers, but they're definitely hardcore users who know CFD and they know all the ins and outs. They're just not actively developing the code.
So a lot of those users end up doing a lot of validation, comparing the results that they're getting from SU2 with the results that they previously gotten from any of the other codes, Fluent, OpenFOAM, and as well as experimental results. So that group also brings a lot to the table, because that brings kind of that trustworthy when you see it compared to different tools that are available.
Yeah, there's this idea that Pyam brought up about transfer of knowledge. So what should our role be? Do we want to make the best code possible, right? We want to have the biggest open source code in the world. We want to have the best CFD solver in the world, right? I think so. So I personally tend to agree with Pyam in the sense that we should get as many people involved. I guess the question is, how do we do that given the resources we have? What is our role as a research group working on a research code like SU2?
one thing to keep in mind that you just mentioned is that this is a research code and is managed by a research group. So one of the biggest points to be able to or show people that this code is worth using is the fact that it's always with new methods is always pioneering along the lines of the computational fluid dynamics world. It's not necessarily going to be the most user-friendly when it comes to really cool GUIs because they don't help you towards your research. A little more friendlier to use, but at least in my mind, the point is to make something that will really be a state-of-the-art code.
Yeah, I mean, I think we're trying to expand this to make it so that as many people as want to develop SU2 and want to use SU2. So while it started out with a research group and like we like to push what the capabilities, there's hopefully other individuals who have also been able to say, hey, I want to have a new tutorial here, a new tutorial there. We're happy for you all to help and build the base knowledge and make it easier to use. Like maybe this certain come across in a tutorial and you're like, well, I created a new tutorial and we were happy to host that on our GitHub site.
Yeah, one thing that came up the past couple weeks and I think is a good point again here today is that as an open source code, we can really tap into a whole world of developers, experts in the field. That's one advantage we have. While maybe we can't do everything that a company can do, given our resources, we do have the broadest base to draw from. So.
And something that we can do that probably a company can't is that we can be extremely transparent. So everything is there. You can validate the code. You will see each subroutine, and it's what it is. It's CFD, and you will have a clear demonstration that is working for several examples. And that's something that a private company typically do not provide. So the kind of validation that you can have in SU2. Because CFD at the end, we know that it works in some cases, and in other cases it's not giving you the perfect answer. So that's also important from open source code.
Yeah. So there are a couple other nice ideas that Pime had in his email that I want to move on to just so we can discuss it a little more. He mentioned working more on active tutorials, so ways to have more tutorials or more engaging tutorials for people to work on, and then also to grow. So having the idea of people submitting their own tutorials and putting them on GitHub and this kind of idea, and even potentially doing competitions or rewards for your tutorials or your work that you submit, and maybe that can help motivate people. So I guess the question is, what do we think about adding more tutorials or changing the style of our tutorials?
So I like the idea of adding more tutorials, and I like the idea of being able to tap unlimited amount of people out there. So we already have so many users who are likely running their own cases, and one of the best ways to just documenting your own case will make a great tutorial. Is like, what do you pick? Why you pick this? Because as you said, like CFD, I don't know. I like to think of it more as an art than as a science. Because for each case you run to get the result you want, you always have to tweak this. You'll have to make the mesh a certain way. You have to make sure to pick this value or that value. And have people who have cases that work that are matched if they just write up a tutorial such that someone else can go and start. Like that's one of the easiest ways to start for someone who's unfamiliar with the code. Is like you just go and do something. Like the first time I was starting with something unsteady, Tom was like, here's an unsteady run. So you look at it, it's like, okay, and now you start changing that and go from there. So I like the idea of having basically a lot of tutorials, and ones that are kind of set up to have the right parameters. And what better way than to actually have people who have worked on this and they finally got their code working, just send it to us, and we might have to think of some sort of tutorial format or something like that. Yeah. And but I don't know, I think it's a good idea.
Yeah, I think that there is a sentence that summarizes this, is that we need you. So there are a lot of things that we really love to do, and we know that one of the main advantages of the open source community is that we can organize the open source community in order to create different, one based on the validation, another one in developing, and that's our objective, and that's the reason we are trying to be more close to the developers, to the users, and so we are not a private company. We cannot put people working in a very particular thing. But we can manage, we can organize the open source community if there are volunteers to do that, of course, a very good idea to have better tutorials.
Like I guess most of us are academic oriented, so like we won't necessarily develop the tutorial, but we're more than glad and help, and that's what we're doing. Like a lot of times we're doing this is because we want to teach something we love. It's like CFD, so we just want to expand this, and so we're happy to help. And then, but
and we know that there are a lot of private companies that are using SU2, and they have the resources to put just a man working on this for 1 hour every day, and just if they contact us, we will help them to do this, and it's going to be useful for everybody.
Yeah. Okay. Any other thoughts on these? I will say I'll jump on the piggyback there at the end of yours. That was sort of how we sort of started. Philosophically, we said, why write a thick user manual? And I think Payam references this. Why write a thick user manual when we can take a bunch of tutorials and teach people step by step, sort of increasing complexity, how to use the code. So I think that's something we certainly want to do. And like you guys are saying, I think if we can get more people involved, that would be great. So.
And some initiatives that are from private companies are really very interested, but we need people. And
now, a good thing to consider will be what's the format of those tutorials that we're going to do, either just a page with instructions accompanied by a config file and a mesh, or do we want to do a little more interactive, like a quick video?
I like the quick videos.
Quick videos,
yeah.
Yeah, and to finish this thought before we move on to questions, I'm glad you brought that up. In the survey, we sent you guys in the YouTube email yesterday. If you check out the survey, we do ask, do you want more screencast or tutorial type videos or type content? So if you guys have a certain desire for different types of content, just let us know. So, okay, I think with that, we better get into some questions. I think we got to move on. So today we're going to do the same thing we've been doing. This time we're going to do 4 questions instead of 5. And just we spent a little more time on the discussion. So again, like last, we're going to dish them off and discuss as a team. The first one we have is from Meng Meng. He says, I'm working on SU2 with our own homemade mesh, and it doesn't have the FFD definition inside of it. That's typical. We usually do this by hand ourselves. Pointwise can export it, but that's a different story. So when it comes to mesh deformation and geometry vectorization, some of these things are kind of difficult to understand or hard to find in the code. So I suppose the question is, where in SU2 do you define things like the design variables, dv kind? So we have surface file displacement. We have all these different variables available. Where are they defined? How do you, there's other options like dv kind, definition dv. So really, how do you come up with or use the parameterizations, the design variables that exist in SU2?
Yeah, this is a very interesting and question, and a lot of people have the same question. So let's try to answer it in the best way possible. So if we are thinking on 3D, at the end, free-form deformation boxes is our best choice. So in this particular case, if you want to use this kind of design variable, the best that you can do is to look for a similar example of you want. At the end, the theory is very simple. So what you're going to do is to have control, you're going to have control of the control point. And the different design variables will be just a coordinate movement of the different control point that you have in this kind of FFT box. So maybe we can go to the computer and show a typical of these boxes. So. So, everything related with grid deformation, design variables, and so on is in a subroutine called grid movement structure. If you go to grid movement structure, then you look for FFD keyword, and you will find that here we have a different set of design variables, different kind of design variable. All of them start with set FFD, just moving, changing a control point, set FFD, set FFD camber, thickness, camber, diagonal, twist angle. So we can go just, for example, to take a look at this one. As I said before, the main idea here is that you have control over all the control points that compose the box. And what you are going to propose is a coordinate movement of this point. So if you take a look at this, the basic idea is that you read the kind of deformation that you want to impose, and this is in param dv. And once you have this kind of deformation, you apply the deformation to the different location of the control point. So you do 3 loops, one over coordinate, j coordinate, and k coordinate that you have in your box. Then you move the point, the control point, to the new position, and that's all. And then you very simple, very easy to modify, and you can use the kind of movement that you want with this FFD strategy. If you go to the config template, just to take a look at this.
Yeah, Francisco, I think I'll add that you've already mentioned it once, but you can couple all of these freeform deformation point movements into more engineering-like variables. So Francisco's going to show you in a second in the config file. You have things like camber, thickness, twist, rotations, and all these types of things. So the same structure that he just showed inside the code, you can sort of combine and use to create new variables that are more like engineering variables.
Mm-hmm. Yep, and that's the main objective that we have when we create this kind of FFD camber, FFD thickness, or FFD rotation, or angles. So the only thing that you need to do is to specify the kind of deformation that you want to apply, the marker, so the surface where you want to apply this kind of deformation. For example, my box, inside the box you have different surface, and you want to apply only this deformation surface, so you specify what's the surface. Then code that basically is a way to explain what kind of deformation you want to apply, and then this is just the amplitude of the deformation that you introduce. So if you want to, for example, apply some kind of angle, you need to specify what's in degrees, what's the angle that you want to twist, that you want to apply. And that's basically all. There are different, very particular deformations, like, for example, surface. There is one in which you can specify .dat file in which you say what should be the new position of all the points in the surface, and then it will automatically move the points in the surface to a new position.
Francisco, I wanted to say a word about that. That's a pretty flexible option since it came up in a question. The surface file option, we realize that some folks might want to use their own geometry parameterization outside the loop, outside of SU2, and be able to just feed in and out the new nodal point coordinates from their surfaces. So basically you can kind of decouple. You don't need to use the parameterization that's inside of SU2. Now I'll also say along with that there are a bunch of 2D ones in the same file, the grid, grid movement, structure.cpp, and you can find a bunch of 2D variables as well. So okay, let's go on to the next question here. So we have a question from Vinoth. So the question is, as far as I have explored, SU2 is taking only the cell neighbors, so the nearest neighbors for the least squares gradient calculation. So 4 neighbors in the case of 2D quads. For my application, I need to calculate the gradients, and I would like to use the vertex neighbors, so I guess neighbors of neighbors in this case. So is there any option to get the vertex neighbor data, another function to get access to that? And so I'll start this one off by just saying that, you know, the least squares algorithm itself, you can go ahead and add as many neighbors as you want to that algorithm, and I'll show you this in just a second. But the idea is you can expand your stencil, if you want to call it that, to include neighbors of neighbors or beyond. And the idea is you include all that information, and then you're still just solving a least square system at the end in order to get the best approximation of the gradient. So really, how much information you put in there is up to you. And I've seen a number of papers. I think there's at least one we were talking about before the broadcast from a turbomachinery group who does this to make sure they have highly accurate gradients. So they include neighbors of neighbors and these kinds of things, and they're weighted least squares. So did you want to add anything?
Yeah, no, I think it's clear. So you can add as many points that you want in order to, but the natural choice is just to choose the stencil. But
if I can jump to the screen real quick,
I think that would be
I'll just show the paper that we definitely would. If you're interested in learning a little more about the least squares, weighted least squares that we're using, feel free to grab this paper. This is a pretty well-known article about the method that we're using. So this is a paper by Professor Mav Riplis. And at the end of the article, if I jump down, there's an appendix that contains. I'll get whirly ball. That's nice. There's an appendix that contains the whole the different terms you need, and it lays it out pretty clearly how you can calculate this thing. So the idea is you're just going to have a set of neighbors, and you can expand that set. So if you go ahead and check this out, in your time, that'd be good. And then real quick, I'll show you where it is that we're doing the least squares calculation. Ooh. Structure?
Yeah, it's in solution
solver
direct
structure
mean.
or direct mean. Yeah, there we go.
And
Got it.
there you have some primitive gradient.
There we go. Primitive gradient least squares. Got it. I think that's moved since I used to.
Yeah, because now we have that in different places. We have in the general solver, but also in the...
Got it. So in here, I won't spend too much time, but you're going to see loops where you're looping over the primitive variables, so you're computing the gradient of each of your primitive variables. You also have control over the neighbors you're using in this calculation, so you could go ahead and expand that if you want, find neighbors of neighbors and access and expand this list. And at the end, you're still just solving a small system in order to get the least squares approximation of the gradient. So that's where you can find this. This will be in each of the solvers, and in particular for solver direct mean, it's in gradient L.
A nice contribution that you can add would be to, because as far as I see, there are a lot of stuff that can be pre-computed. So you have a wall and you want to pre-compute all those geometrical stuff that you use in least square, just send us an email and create what's the name we have is
Pull request?
Pull request.
Yeah.
So this is going to be very useful, a very nice contribution. We pre-compute a lot of the geometrical stuff that we have in the least square implementation.
Okay, let's keep moving. So the next question is from, the question is, it's actually two related, but the first question is min-mod still an option for slope limiters in the newest version? I can't find it. When I try to use min-mod, it throws some errors. And then I'll just go ahead and say the second part is related. It's from Eamon. It's I am unable to locate the class function which reconstructs the primitive variables for the second order reconstruction. Can someone help me with this reconstruction in the code? So
for this question, I just want to take a step back and kind of talk a little bit of what we have available in the code and what it means to need a limiter, first order, second order. So in the code we have available is a first order solver as well as a second order solver. When we are using first order, there is no need for a limiter. We're just assuming that the magnitude of each one of the variables in each one of the cells where you're computing is a constant. But when you are assuming it to be a second order, it becomes a linear type function. And when computing the gradient, sometimes it will try to go out of bounds when you're extrapolating from this linear function. And that's when the limiters need to be implemented to stop what's the growth of this linear function when you're extrapolating it. And in the config file, I'm going to jump to the computer real quick. We have the option, let me just see if I can use this. So if you go to the config template, here you go. You have in the flow numerical method definition, you're going to have the option to choose the different numerical methods. When you're using a central method, just such as JST, the limiters are not implemented in the same way. For that one, you use this first, second dissipation coefficients, which serve a similar purpose. But when you're using something that is an F1 type method, such as cusp, rho, AUSM, HLLC, you are going to need, or if you decide to go second order, you will need to choose a limiter. In the case of our config file, you can use it as a first order method. You can use it as a second order method without a limiter and just kind of take your chances, see if it works. Or you can use it as a second order with a limiter. And the limiters that we have currently available are the Bankert-Decreuzen and the Barth type limiters. And unfortunately, we don't have them in mod anymore. We decided to not continue using it. But these two limiters have been proven to be very robust.
Yeah, so I would go ahead and use one of those limiters as opposed to min-mod. That's likely what you get in the errors. I'll just stay on the computer as well. and I'll show you where this reconstruction takes place. That's part of the second part of the question. So if you go to solver direct mean, and you look for Euler, I believe it is. Euler sort of upwind residual. So let's grid movement. So here it says, so we picked in the config file if we wanted an upwind scheme and then first order or second order. And let's just say we picked first order, so we're not in this second order loop. So then the else statement is we just set the primitive variable as, we just set the primitive variable. We don't have to reconstruct it. So if we have second order, let's go down here. And so here's where here's what David said, where we actually use the gradient for the second order reconstruction. So if we have a limiter, we have the limiter that multiplies the projected gradient. If not, if we don't have the limiter, we just go ahead and have the value plus the gradient in the direction of the between the 2 points. So again, this is in solver direct mean and in the method upwind residual, Euler solver. So yeah. You guys want to add anything?
Yeah, why don't so with respect to the limiter value, maybe I can show where we compute the limiter. I think that would be also useful. And okay, so we typically compute the limiter for Euler in set primitive limiter, and this is the main subroutine that we use. As David said before, we are using these bars kind of limiter or the Cataclysm limiter. But again, there are a lot of different kind of limiter, and it would be great if you can implement your own limiter or a well-known limiter and test it. There are, I think it's very easy. All these limiters are quite similar in the way they are implemented. So it would be great if you have a chance to implement a new limiter and send us your feedback and the results. Do you want to add anything else?
No, I think we should just move right on to the last question. I think that was good. Thanks, guys. Okay, so the last question is from Steven. It says, hello, I want to use SU2 on a cluster, so specifying a machine file is what I must do. However, I'm not familiar with Python. Can somebody tell me where to modify the scripts? So we do get this question a lot. I think every cluster is a little bit different, but there are some sets of the resource managers. There's Slurm, there's PBS, there's Torque, or whatever it's called now. So there's some standard ones, and a lot of the job scripts end up looking the same. So what I'd like to do just for a minute or two, our last minute, is go through a couple job script examples of using SU2, and then if I can, just show you where in the Python you can make the changes to the call to either MPI run or MPI exec or whatever you need for your particular application. So I'm going to jump over to the screen too. All right, first, just to show you a little bit about what a job script might look like. I have over here two different job scripts. One is a PBS script, and one is a Slurm job script. So they're going to look very similar, but they have their nuances. They're slightly different. So first, let's open the job script PBS. So this is a job script it's kind of generic. It'll work for a PBS, or I think Torque now is another name for it, job scheduler or resource manager. And so you have the typical kind of setup where the pounds and then followed by PBS. These are all options. So you're doing things like requesting a number of nodes and processors per node on a certain cluster. You specify wall time. You pass along environment variables. And then the key is at the end for us, if you have your Python environment all set up the way we recommend in the installation, you can go ahead and right here in the job script call parallel computation or finite differences or shape design. And the key is that deep down in the Python infrastructure, there's a line that's going to understand how to call the parallel job. So usually using MPI run, but Slurm, for instance, uses srun. So in a moment, I'll show you where that is. Just as another quick example, here's a Slurm file. So Slurm is a little bit different, but you can kind of see that these things are all somewhat similar. You have a pound and then an S batch. So this is again a keyword saying that you're about to specify some options. So you can give it a job name, some output, error file, number of cores in this case. I'm requesting 36. And then here I'm doing it manually rather than calling Python. I'm calling the partitioner and the CFD code. And here I'm using srun. So that's Slurm's option for booting up parallel jobs. That's its launcher. It's srun. So it says -n36, so run this on the 36 cores. And just a thing I like to do at the end of the line is I always just direct my output into a file for each of these. That's something you might like to do.
Just a small detail, but you must be sure that you have compiled using MPI and everything should be in parallel. So that's important. And the version that you're using for your compiler should be the same version that you have when you initialize your scripts.
Yeah, and then the last thing I'm going to do here is dip down and find where it is that we specify the launcher. If I'm lucky, I'll
Yep, at the very beginning, I think.
I'll find it right away. There we go. First try. Okay, so if you really need a special kind of setup for your cluster, this is something you can do. What I've done is I've gone down inside of the SU2 Pi folder, and inside of there's an SU2 folder that has kind of the guts of the Python, the inner class workings, and inside of the run folder there's a file named interface.py. So if you pop that open, this is what controls the actual command line launching of the job as you call through our parallel Python script or finite differences or shape design. And at the top of the file, one of the first things you're going to see in here is it's actually building the text string that it's going to send to the command line. And so right here, we have hooked it up to understand Slurm just because we have our own internal cluster that uses Slurm, so we kind of we have this option for ourselves. But you could very easily come in here and modify this to be whatever you'd like. So if you need to use MPI run or MPI exec, or like you're saying, maybe you need to add a host file or a machine file with all the nodes that you're going to run on, you can go ahead and add that information right here. And it's going to show up when you run that job script that calls the Python. So the Python's going to do it for you if you put it in right
do not forget that you need to make install after any modification that you implement in the Python script.
Good idea. Yeah, we install the Python scripts the same way that we do the executable. So after you compile, you're going to want to go ahead and install those, like Francisco was saying. It'll copy them into place so that you get the right files. So, okay, well, I think that's it. I think we're about out of time. So any final comments, guys? Any thoughts?
Yeah, just try the new version.
Yeah, the new version, and just keep posting on the forum. And
Yeah,
if you
and-
have developers' questions, send them to the list.
Yeah, and lastly, I'll encourage you to please join the developers list because I think we're going to start having some great conversation and discussion. I mean, a great email from Pyam, so look forward to that. And lastly, please do, if you have the chance, take the time to give us a little bit of feedback on the format on the survey we sent out yesterday. So, okay, guys, let's call it a day.
Bye.